Let's see what the procedure is to graph a cosine or sine function. The first step is to find the amplitude. And recall from our functions y equals a sine bx or y equals a cosine bx, the a, or the constant in front of my function, is going to determine the amplitude. So the amplitude is equal to the absolute value of that constant in front of my two functions. Next, they want us to find the period. And the period for each is going to be the same, which is 2 pi divided by b, or divided by the constant that is inside my function. Then what we want to do is multiply your period by 1/4 to find your quarter points. The reason for that is if we take a look at the previous diagram, we have quarter points. Here the quarter points are at 0. And even though it's not shown here, this would be pi over 2. This would be at pi. This would be at 3 pi over 2. And this would be at 2 pi. And we could take this on the negative end or continue to the positive end. The quarter points that they're talking about are these quadrant angles in this situation when my period is 2 pi. These quarter points change as my period changes, but they're determined by multiplying by 1/4 and can be graphed similarly as this function has been. Next, create the graph using your quarter points. And we know that what I start with is what I'm going to end with. And what we want to do is graph a positive or to right of the y-axis or a negative section, and that would be to the left of the y-axis. And then we create a smooth curve. And again, recall what you finished with is what you started with. I will put this slide on our group resource page. Let's start with our first example. And let's go back to this previous slide. And I'm going to graph just px equals sine x. Hopefully you have the procedures in front of you and follow along. Step 1 is to find the amplitude. And recall the amplitude is the constant that is in front of my function. Here, my a is 1. Therefore, my amplitude is the absolute value of 1, or 1. Next, I need to find my period. Remember, my period is going to be equal to 2 pi divided by b. In this situation, again, it's the constant that's inside my function, and here it is 1. So my period is 2 pi. Then step 3 is to find my quarter points. So again, 1, 2, 3. And my quarter point is to take my period and divide by 4, or multiply by 1/4. So 2 pi times 1/4, which will equal 2 pi over 4, or pi over 2. Now to graph, all I'm going to do is to count by 1 pi over 2 until I get to my period, which is 2 pi. Or in this case, it would be 4 pi over 2, which is 2 pi. So if I count 0, 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and here would be 4 pi over 2, which is 2 pi. So how do I determine the values at the quarter points, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi? Well, I've been referring to this as the quadrant angles. And if we go back to our resource page, I have quadrant angles shown, and here I have the sine of theta. At 0 degrees is 0. At 90 degrees is 1. At 180 degrees is 0. And 270 is a negative 1. And 360 is 0 again. Recall, this is 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. So for all sine functions, I'm going to put 0, 1, 0, negative 1, 0 for my quarter points. For cosine, I'm going to start with 1, 0, negative 1, 0, and 1. The only thing that's going to determine what this 1 is going to be is the amplitude. So the zeros will stay the same for cosine and sine. The amplitude is going to be the value at the other two quarter points. So if I go back to my function, 0 radians, I start at 0 for sine. At pi over 2, that's going to be at 1. At 2 pi over 2, or pi radians, it's going to go back to 0. At 3 pi over 2 radians, I go to a negative 1. And at 2 pi radians, I finish the function with what I started with, which is 0. Another diagram to look at to represent the quadrant angles or quarter points is if I took the sine function, which we just found, to have quarter points at 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi, that I have 0, 1, 0, negative 1, and 0. If I had 3 sine x, this amplitude would be 3. Then at those quarter points, the function values are not going to be 1. The amplitude will be 3 or a negative 3 at those quarter points. So that makes it easy to graph these functions when I know that sine is going to start with 0 and end with 0. The only thing I need to determine is the quarter points and what the amplitude and the value I'm going to graph at those quarter points. Let's look at another example. Here, y equals 4 sine x. I also have the general function of y equals a sine bx. Step 1 tells us to find the amplitude. The amplitude is going to be the absolute value of a. That's our value in front of our function, which is going to be the absolute value of 4. So our amplitude is 4. Number 2, I have to find the period. And the period is equal to 2 pi over b. And here, my value of b inside my function is 1. So that's going to be just 2 pi over 1, or just 2 pi. The third part is to find my quarter point, which is to take my period and multiply by 1/4. And this will be 2 pi over 4, or 1 pi over 2. Now let's create a graph. So I have my y and my x-axis. I'm going to start at 0 radians. My quarter point is 1 pi over 2. I'm going to count by 1 pi over 2 until I get to my period, which is 2 pi. So that is going to be pi over 2, or 1 pi over 2. Next is going to be 2 pi over 2, which is just going to be pi. Next is going to be 3 pi over 2. And my last value is going to be 4 pi over 2, or 2 pi. That is from the beginning to the end, one period. And now all I have to do is recall my quarter point, which is going to be the sine of x, and my value of my amplitude is 4. So 1, 2, 3, 4. 1, 2, 3, 4. And remember, the quarter points of sine starts with 0. Then at each quarter point, I'm going to have a point with my quadrant angle of pi over 2. This goes to 4 rather than 1, since my amplitude is 4. Back down to pi, which is 0, to 3 pi over 2, which is 4, and back to 2 pi over 4 pi over 2, or 2 pi, which is 0. Then a smooth curve to connect the function, which is going to be as demonstrated. That gives me one period of 4 sine x. Let's take a look at another example. Y equals a negative 2 sine x. We're going to follow the same procedure. Step 1, finding the amplitude. The amplitude here is going to be the absolute value of a negative 2, which is 2. The period is going to be 2 pi divided by b. And again, my b is going to be 1. The interior of the function has a constant of 1, so it's 2 pi over 1, or 2 pi. My quarter point is going to be my period multiplied by 1/4. 2 pi times 1/4, which is going to be 2 pi over 4, or pi over 2. Now all I need to do is to graph this function. So we start out with a y-axis, x-axis. Again, we have a 0 radians. Then we're going to count by my quarter point, which is pi over 2, or 1 pi over 2, until I get to 2 pi. So 1 pi over 2, or pi over 2. 2 pi over 2, or pi. 3 pi over 2, and finally 4 pi over 2, or 2 pi. Now, remember with the sine function, my quadrant angles are going to be 0, 1, 0, -1, 0. But I have two different situations here. One, my amplitude is 2, so instead of 1, it's going to be a value of 2 at my amplitudes. And I also have a negative value for my amplitude that we start with. So I'm still going to start with 0, but since this is a negative function, I'm going to go down 2 to start, and then I'll go up 2. So it's just going to do the opposite rotation of my function. So 0, -2, 0, 2, and back to 0. Again, starting with 0, ending with 0. Now I'm just going to generate a smooth curve. And this function is representation of a -2 sine x. I'm going to do quite a few examples in this section, so you can always stop and start the video depending on a problem you may have through the sections. So let's take a look at one more. Y equals 3 cosine x. I'm going to follow the same procedure again. I'm going to find the amplitude. The amplitude is going to be the constant in front of my function, which is 3. So the absolute value of 3 is 3. The period, again, is going to be 2 pi over b. And b has a value of 1, the constant inside my function, so 2 pi over 1 is 2 pi. My quarter point is going to be my period times 1/4, 2 pi times 1/4, which is going to equal 2 pi over 4, or pi over 2. And remember, all I'm going to do is count by ones, 1 over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, until I reach my period. So now all I need to do is to graph the function, creating a y-axis and an x-axis. And let's count by 1 pi over 2 until we get to 2 pi. So 1 pi over 2, or pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and 4 pi over 2, which is 2 pi, reaching my period. Now, recall that my cosine function starts with a value at 0 radians to be 1, then going to 0, -1, 0, and ending with 1, because where you start at is where you need to finish. But here my amplitude is 3. So I'm just going to start at 3 at 0 radians, and then repeat the process to my rotation of a period. So 3 to 0 to -3 to 0, and then back to +3. Then we just complete a smooth curve. And that is a representation of y equals 3 cosine x.